Hi everyone, it's Rohan this side, and in this video, I'm going to share a very unique question on the complex numbers and Argand diagrams that came in the May June 2017 Cambridge examinations in their paper 3.3, and I'm specifically talking about question 11. And now the format of this video will be such that we are going to go through the question along with me, and then pause the video over there and try to attempt that question once you are done understanding it in order for you to check that based on the current knowledge of the complex numbers and Argand diagrams, if you were able to solve this unique question by yourself. Once you are done giving an attempt, you can resume the video, and then we are going to go through the some of the most common mistakes that students have made who appeared on this paper for the specific questions by going through the examiner report. And then you can let me know in the comments that if you were someone who made a similar mistake. And regardless of this, I'll also show you how I would be solving this question for the students who are completely clueless about how we can go about this question. So yes, guys, let's get started. Now, at the starting of the question itself, they have highlighted a statement that throughout this whole question, the use of calculator is not allowed. Now, whenever they write this kind of a statement, I always ask you guys to use your brain because there will be certain kind of techniques that your brain will be able to inform to you that how easily you can solve this kind of questions. But now let's say if you're having calculator in your hands, you will be going towards some of the techniques that calculators can easily solve it. But if you have to do it by yourself, it will take a lot of time. And that is why I recommend students that try to avoid the calci and utilize your brain in order to solve this kind of questions. Now, the first part of the question states that there are two different complex numbers, z and w, which are satisfying these two equations with the two unknowns. And we are asked to solve these equations for the z and w, where we have to give our final answers in the format of x plus iy, where of course x and y are the real numbers. This question is for 6 marks, and to be honest, if you ask me, this part of the question is not that tricky as compared to the second part, but still there were a lot of comments made by the examiner where they mentioned about what are the different kind of common mistakes that students have made on this particular question. So yes, guys, I'll ask you to pause the video over here and first try it by yourself and then come back once you are done. Alright guys, so welcome back. If you did, give it an attempt. And the first thing we're going to look into is the general comments by the examiner that for the no calculators allowed question, please make sure that you are showing all the steps in order for you to not lose any kind of method marks which is leading you to the final answer. Now let's move on towards the specific comments by the examiner for the first part of this question. So the first error that students had made were the solutions were not really clean and tidy. Because of that, students themselves were getting confused that if they have written I or 1 or if they had written Z or 2. So please make sure that you are writing your solutions neatly and clearly in order to avoid this kind of confusions. The second common mistake was, even though Z and W were two different complex numbers, because in the question that they asked us to write your final answer in the format of x plus iy, there were a lot of students who just said that Z and W both are x and iy. So they substituted the values of Z and W as x plus iy, which eventually led them to the incorrect answer. So just note that guys, Z and W are two different complex numbers. I hope you are not someone who have done this specific error. And now the third point is that there are a lot of different ways to solve this question, but please make sure that you're choosing the method that is least time consuming. And that is why for the no calculator questions, if you're using your brain, you will be able to think about this kind of a method that's going to consume very least amount of time and you will be able to solve it very quickly. But there were some students who substituted Z as x plus iy and W as a plus ib, which was not an incorrect approach. But the problem with this was that you're having now four different unknowns, and because of which your equations are going to be very complex to solve without an aid of the calculator. So, what is an easier approach over here so that you cannot lose any kind of method marks without the calc? You can solve it very easily. Basically, just treat these two equations with two different unknowns. Let's say, for example, you make z the subject of formula, and then just substitute the whole equation in this equation and solve for w. Once you get the W, substitute W back into this equation and solve for Z. That will be the easiest possible method. So I hope that this has given you some idea of how you can attempt this question. Now, before I actually go ahead and show you step by step how you're supposed to do this, there was one more point written in the examiner report that a lot of students indeed got a correct answer, but they were not writing it in the format of x plus iy, because of which they are losing the final mark out of 6. So yeah, if you're getting the values of x and y, just make sure that you're writing that your z is equals to that and w is equals to that. Now, keeping all these mistakes in my mind, Here is a complete step-by-step solution that I've written for you guys for the first part. The value of W that you should be getting is minus 1 by 5 plus 2 by 5i, and the value of Z that you should be getting is 3 by 5 plus 4 by 5i. If you got this, congratulations, you can move to the second part. But now for the students who did not get it correct, I am over here to guide you very quickly. Now, based on the poll that I've taken on my WhatsApp groups, that for this kind of videos, should I explain each steps in a detailed way, or should I just give you an overview? Because obviously, this kind of videos are targeted not for the beginners, but for the students whose at least the basics are clear and they want to challenge themselves. So yeah, most of you guys told me that even the overview is just fine. And then if you're having any kind of doubts, you can either post it in the comments or maybe on our WhatsApp group. So yes, guys, if you want to be part of this kind of discussions, the link for the WhatsApp groups are posted in the description of this video. You can join us and you can also be part of this kind of discussions for the future videos. But yeah, let's get started with the first part. So the first thing that I've done over here is I've just made labeling for the equations. This is my equation 1 and this is my equation 2. Then I've written that from my first equation, I'm going to make Z the subject of formula. And then I'm going to take that Z and substitute it in my second equation so that all the Z's are now in the format of W. And now I'm just going to use my algebraic skills to solve for W in the format of x plus iy. So I opened the brackets over here, and please keep in mind that whenever you're going to multiply the i's, the value of I square is negative 1. So try to avoid as many sign mistakes over here. If you want, you can take a whole minute to open the brackets over here so that you are comfortable before you go towards the next step. Now, after this, I realized that in order to solve for W, I just need to take W as a common factor. That is what I've done over here and sent everything else to the right hand side. After that, this is the step where I ended up on and said that my W is equal to this. But now currently it's not in the format of x plus iy because there is an extra complex number in the denominator. So to eliminate that, what do? We just take the complex conjugate of the complex number in the denominator and multiply that with the fraction's top part and the bottom part. And after opening the brackets, the final value of W that I got in the form of x plus iy is this. Then the next step would be to take that W and substitute that in my first equation so that now I can replace this W in the format of some kind of a complex number. And then I just solve this ahead to get my Z in the format of x plus iy. And that is exactly what I've done over here. I've carefully opened the bracket step by step. I'm just keeping on solving it as much as possible without doing any kind of mistakes. And finally, I ended up my Z being this particular answer. So that is how you solve the first part of this question. And it's now time to move on to the second part. By the way, guys, if you're having any kind of doubts over here in my explanations, please don't forget to comment it down, or maybe you can ask it on my WhatsApp group also. But yes, now let's move on to the second part, which is the most unique question that I've seen in the history of complex numbers, as asked in the previous years in the Cambridge examinations. So it's given that the complex numbers u and v are u is equal to this, v is equal to this. And now in an Argand diagram, these complex numbers u and v are represented by the points a and b. Now there is a third point c which is lying in the first quadrant, and it's given such that bc is equals to 2ab. And now the angle between the ab and bc is also given to us as 90 degrees. So it's pretty clear to us that c is in the first quadrant and BA and BC makes 90 degrees, which means they are perpendicular to each other. Now we are supposed to find the complex number Z, which is represented by the point C, giving our final answers in this format of x plus iy, where x and y both must be real and exact. So yes, guys, just go ahead and pause the video over here. I'm really looking forward to see that how many of you guys are able to solve this correctly in the first attempt. Yeah. So yeah, just pause the video over here and come back once you're ready. Now, welcome back, guys. If you did give it an attempt, and if you have yet not attempted this, trust me, guys, you are just wasting your time by watching this kind of videos because I'm telling you, it's not at all going to help you. The main motto of doing this kind of questions is to help you evolve your capacity of thinking more than just the normal questions. And it's only possible when you first attempt this kind of questions by yourself, do some mistakes, but then try to think more and try to get to the solutions. Yet, even if you're failing, that's completely fine. But doing this process, you're telling your brain that, dude, you need to think more than the normal questions. And that is what is required such that in the final examinations, if you get this kind of questions, you indeed have a capacity to think in a proper direction. So yes, guys, if you are just watching these videos without trying this kind of questions by yourself first, you are simply wasting your time. That's a harsh truth. All right, guys. But yeah, for the students who did give it an attempt, very congratulations first of all to you guys. Even though if it's incorrect or if you just left the solutions in middle, it's completely fine given that you have at least thought about something, right? But yes, guys, now let's look into some of the comments made by the examiner for the second part. They have mentioned that if the students have used either of the vector or just the coordinate geometry methods, they typically used a very long calculations to get to the final answer for just a 4 marker question, which indicates that because of this, they are utilizing a lot of time in this question. They were not able to solve the remaining part of the paper. And therefore, the best way to solve this particular part is to use the concept of multiplication of the two complex numbers. I'm sure a lot of you guys must be confused over here that why are we using multiplications of the two complex numbers for this part? Well, that's what I'm about to show. So yes, let's get started. And that's how the step-by-step solution is going to look like for this part. And the final value of z that you must be getting for it to be correct is 4 root 3 minus 1 plus 6i. And if you were able to get this solution by yourself, please let me know in the comments. I'll be really very happy to see that how many of my viewers are able to get to the solution by themselves. Now, for the students who were not able to solve this particular part, it's completely fine. I'll show you that how I have done it. All right. So first of all, just to imagine what's really going on in the question, I've drawn a rough Argand diagram over here. I have plotted my points A and B because I know that my A point is 1 plus 2 root 3i, so that is 1 and 2 root 3i over there. So basically, this is my complex number U. Similarly, 3 plus 2i is over here, that's my complex number V. And now for the C, they told me that my AB and BC were perpendicular to each other. So now there are only two possibilities where I can have my C, either over here or obviously somewhere over here. Now the reason I have not said that it's on the bottom, it's because C lies in the first quadrant. So first quadrant is over here. And that is why this is the rough scenario that I have drawn over here, just to get the initial ideas of how I should begin the question. Alright, so now the plan over here is that I'll be utilizing the concepts of vectors and complex numbers in order to find the point C, which is eventually the complex number Z that we are trying to find in the format of x plus iy. So how am I planning to do this? First of all, I'll be finding the vector b to a. Okay, what is this vector b to a? Because I'm already aware about what is the point b and point a, I can easily find this vector. Now once I'm finding this vector, I'm going to rotate this 90 degrees in the clockwise direction so that it's going to look something like this over here. But I know that BC is twice the AB. So after rotating this vector BA, I'm simply going to multiply it by 2 so that I can go from B to C. So I'll be able to find a BC vector. And once I'm having a BC vector, I know that I can find my vector C with the help of this particular vector rule. So yes, guys, that's the whole idea over here. And before we start executing upon that, let me first help you understand that if I'm given a particular complex number, and if I have to rotate that complex number either in the clockwise or the anti-clockwise direction, how can I do that? And I'm going to demonstrate this with a very simple example. Let's say I am having a complex number I, and I'm going to mark it over here like this. And let's say if I want to rotate this complex number 90 degrees in the anti-clockwise direction. So it is going to be finally ending up over here. This complex number, if I rotate 90 degrees in the anti-clockwise direction, this is where I'm going to end upon. So how is it possible that I can take my given complex number and get a new complex number which is a rotation of the current complex number? Well, we think in terms of arguments of the complex numbers over here. So currently for the given complex number I know that it is having an argument of positive pi by 2. And the whole aim is to take this particular complex number and rotate it further by pi by 2, because 90 degrees is pi by 2. So I'll need to rotate this with pi by 2. So from this positive real axis, I know that in order to go till the rotated complex number, I'll need to have a total of pi as my argument for that complex number. Now, just like this, let's say if I wanted to rotate my eye uh, 45 degrees in the anti-clockwise direction, then how it's going to look like in that case, right? I'm again going to draw a rough diagram, and my complex number was I, and let's say if I want to now rotate it 45 degrees over here. So what will be the plan, right? So I know that this is my pi by 2, and I further need to rotate it in the anti-clockwise direction by pi by 4, because pi by 4 is 45 degrees. So from the positive real axis, what is that angle? It is pi by 2 plus pi by 4. So this is a complex number whose argument is this. And I know that uh, there is a way through which I can write it in the polar format, that is e to the power of I theta, where theta is my argument of the complex number. And obviously there is also a modulus of the complex number r over here. So let's say that for now we are ignoring any kind of changes in the length of the complex number. We are just focusing upon if we are having a particular complex number and if we have to rotate it, how we can do it. So over here, the value of this theta or the argument to get this complex number would be pi by 2 plus pi by 4. That is going to be equaling to 3 pi by 4. So if I'm having e to the power of I 3 pi by 4, I can open this as what? Cos of 3 pi by 4 plus I sine 3 pi by 4. So now whatever is this value from your calci, you can find it out, and you will be getting a complex number that is a rotation of this given complex number, that is 45 degrees in the anti-clockwise direction. And just like this, if I want to give one more example, that instead of rotating I in the anti-clockwise direction, let's say if I now want to rotate it in the clockwise direction by 90 degrees. So what's going to happen? Now it's going to be over here. So how can I go from my current argument in this direction? Remember that the clockwise angles are always negative. So over here, I want the argument of my complex number to be 0, because the angle with the positive real axis is 0. So e to the power of I0 is your complex number, which is the rotation that we get of this I in the 90 degrees and clockwise direction. Okay, that is basically my pi by 2 was the current value of the I, the argument of the I, and then I'm doing minus pi by 2 to it, so that I'm now going in the clockwise direction 90 degrees. That is how I got 0 over here. And then if you do cos of 0 plus I sine of 0, it is going to be equal to 1 plus 0i, that is 1. And over here you can see that indeed it is 1. So I hope that you got the idea about how we can rotate a particular complex number. Now sometimes what's going to happen is that over here we know that I was a very simple example. So we were able to find its argument that was in the exact terms. Now sometimes what's going to happen is your complex number is going to become really very weird, such that you cannot really find the exact value of the argument. It will be in some kind of decimals, not an exact number. So in that case, if you still want a final rotated output of the complex number in the exact terms like what is demanded in this question, how we can go about this? So the idea over there is, over here we know that in order to get the rotation effect of a particular complex number, we do e to the power of I of the current argument plus the new value of theta. So if I have to split this, I can say that this is same as writing e to the power of I pi by 2 into e to the power of I theta. So this was my original complex number. And then if I multiply this complex number with a new complex number whose argument is theta, so I can still get the rotational effect. And this time, because this I am expressing in the exact terms, this can be expressed in the exact terms. I can multiply these two complex numbers such that the output over here would be the exact complex numbers without having any kind of decimals involved. So I hope that both the ideas are clear. If we are able to express our given complex number in the exact format of argument, and then if I know that the rotation angle is whatever angle, either in the plus or the negative direction, I can directly say that my rotated output will be e to the power of I of that summation of the two angles. But now if one of the angles I cannot express in the exact terms, In that case, I can just separate this both of the complex number. My first complex number is already given to me. I'll just find what is the another complex number by opening my e to the power of I theta, because I know that e to the power of I theta can be expressed as cos of theta plus I sine of theta. So I can get this complex number in the format of a plus ib. And then I can multiply this a plus ib with the given complex number, something like this, to get the answer that is in the exact terms. I hope now this is pretty clear to you all. And now we can start executing upon our idea. So the first step was to get our BA vector, and my BA vector can be found by doing OA minus OB. So that's my OA minus OB to get this BA vector. And now that I'm having my BA vector, I'm expressing that in the format of complex numbers. Now, because it's in the format of a complex number, I can say that on my Argand plane, it is somewhere over here, where I know that the value of the real part is -2, somewhere over here, and this part is in the imaginary axis. So that is how I get this complex number over here, which I now need to rotate 90 degrees in the clockwise direction so that I get something like this over here. This BA vector, I want to convert it over here. So how can I do it? If you try to calculate the argument of this complex number, you will see that it's not coming out in the exact terms. You can try to calculate it by yourself. And because of this, what I'll do is I'll take this original complex number and then just multiply it with another complex number whose argument is going to become minus pi by 2, because minus because I'm rotating in the clockwise direction, and pi by 2 because it's 90 degrees. So I just need to multiply this with e to the power of I minus pi by 2. So now what is this e to the power of I of minus pi by 2? Well, I can open this in the format of cos minus pi by 2 plus I sine minus pi by 2. And in doing so, I'll be getting the output of this complex number as negative I. So this is what, if I take my original complex number and multiply it with a negative I, I'll get a 90 degrees rotation in the clockwise direction. But now I also need to double this particular output. So that's why I'm also multiplying this result with 2 so that I can get that multiplication effect over here of doubling my current complex number. So I hope that this whole idea is clear to you, that how I'm going to take my current complex number, and then on top of that I'm going to multiply the multiplication factor that comes from the additional argument of minus pi by 2 to rotate my current complex number in the 90 degrees in the clockwise direction. And then the 2 is added over here to get this particular effect. And that is what I have achieved over here, that my BC vector is same as this particular vector. Now I need to take this vector and shift it on top of the B so that I can get to C. So I can now do it either in the format of vectors, or I can directly say that in order to go from here to B, I'll need to go 3 units in the x-axis and 2 units in the y-axis. And then I can say that that is how I can get C. Or else if I want to follow my vector approach, because I already found out what is my BC, over here it's 4 root 3 minus 4 plus 4i. I can say that my BC is equal to OC minus OB. OC is what I need to find. So I'll make OC the subject so that I get BC plus OB. This is my BC that I'm getting from here. This is the OB that I told you that I need to add 3 in the x and 2 in the y direction. And that's how I'll get my final OC in this particular way. And that's how I am getting my final value of the OC, or basically the point C, which is represented by the complex number Z, as 4 root 3 minus 1 plus 6i. So I hope that you were able to understand everything for this specific part, because this was one of the part that was requested by a lot of students. And thanks to our student Kintu, who has sent this particular question to us. And if you're also having this kind of challenging and interesting questions, you can also share this kind of questions with us from the link that is provided in the description of this video. Just open that Google form and submit your questions. And if it's really very unique and difficult question, we'll surely make a video upon that as well and give you credits for the same. So thank you guys for watching this video, and don't forget to like this video and share it with the students who may get stuck upon this particular question.